Okay, you're gonna have to give me your feedback on whether you think this is a good thing or a bad thing. I've got it on the positive right now instead of the negative, which is normally what I do. But let me know in class. Give me some feedback on whether you like it or not. Anyway, back to the old days of division in elementary school. We would say 13 does not go into the 2. 13 does go into 28 two times. The big question I have for you right now is do we take the 2 times the 10, or the 2 times the 3, or the 2 times both the 10 and the 3? Now, obviously, all of you would say 2 times both of them, the 10 and the 3. Normally, we would say 2 times 13, but it is taking it times the 10 and the 3, so you're multiplying it times everything there, not just one thing. And then typically what we would do is we would subtract. Now, you're going to hear me say things like distribute a negative 1 and add. Now, that's the same thing. Subtraction and distributing and a negative 1 and adding are the same thing. There's a reason why I'm saying that, and when we get to class, you'll see why. Now, the next thing I need to do is carry down my next term, which is the 7 there. And 13 goes into 27 two times. And then I take the 2 times the 13, and I get 26. And I subtract, and I get 1. And we are big boys and girls. We are not going to write R1 like some kind of weird pirate remainder. That's what we did in elementary school. Nobody ever does that. People do things like 22 and 1/13, right? In other words, the remainder goes up here. What you're dividing by is your denominator, right? That's called your divisor. You got your remainder, your divisor, right? So that's how we would go about describing that, your remainder. Now, nobody's ever going to write it like this, but that's how we're going to write it when we get to polynomials. Nobody's ever going to write it like this, but that's how we're going to write it when we get to polynomials. So in other words, we're going to have the terms separated out, and you'll see that in the polynomials. You never see that with numbers because we just add everything together. We can't really do that with unlike terms. So in example 1, we're talking about division here, long division. The top thing is called your dividend, and your bottom expression is called your divisor. Talked a little bit about that term divisor a second ago. The dividend is equal to the quotient. Dividend over the divisor is equal to the quotient plus the remainder. Quotient meaning answer to the division problem. But there could be a remainder. Obviously, there always is a remainder, even if the remainder is 0. If you want to check your work, you take the dividend, and that is equal to the divisor times the quotient plus the remainder. So you take this quotient plus remainder, you multiply it times the divisor, and that gives you the dividend. I know most of you don't like to check things, but that is a good way to check your work. So let's see, how does this whole long division process work for polynomials? Well, the first thing I want you to realize is that we take the first term, the x squared, and we divide by the x. In other words, I'm focusing my attention on those two things right there, the x squared and the x. And I'm dividing them. And whatever I get when I simplify that, I get 1x. Now, I don't just take the x times that x, I take the x times both the x and the negative 3, giving me x squared minus 3x. Now, some of you would probably be fine if we just said subtract, but many of you will not be, so I am going to distribute a negative 1 and add. And by distributing a negative 1 and adding, we have less confusion. Lots of you would end up with 0x right there because you would have done the wrong operation. All of you are pretty good at subtracting those two and realizing that they cancel out. But lots of you get confused when you start dealing with this one. That's why I say distribute a negative 1 and add. Then I can carry down my minus 12. Now I'm going to focus my attention on the 6x and the 1x. 6x divided by 1x. Whatever I get out of that is the next thing. It is a positive 6. And now I'm going to multiply the 6 times the x and the minus 3, giving me 6x minus 18. Distribute the negative 1 and add, giving me a remainder of 6. So my answer to this is x plus 6 plus 6 over x minus 3. My remainder is not going to be written like the book does, where it says r. X plus 6 plus the remainder over the divisor. So what's a factor? Example 2 starts talking about this term factor. A factor is a number or expression which divides in evenly with the remainder equal to 0. We know that kind of thing, like we could say that 3 is a factor of 6 because it divides in evenly. So the question is, x plus 4, a factor of x squared plus 6x plus 8. Well, in order to check that out, we're going to do some division, right? So we got our x squared over x. Focusing on this one and this one. Okay, multiplying both of those. X squared plus 4x. Distributing our negative 1. Adding. Carrying down the 8. Focus our attention on the 2x and the 1x. 2x and 1x, divide those two and you get plus 2. Multiply those, you get 2x plus 8. Distribute your negative 1. We get a remainder of 0. That's good news. So, yes, comma, x plus 4 is a factor of x squared plus 6x plus 8, since the remainder is 0. That's great practice in case I ask you to explain your answer, justify, give your reason, why. All of those need a sentence answer, and I'll talk about that in class. Okay, next on the agenda. There's another way to handle these problems called synthetic division. Synthetic division uses the 0 which comes from the factor. I'll show you what I mean by that and remind you about that, which you should have been reminded about yesterday. We are also going to be switching the sign so that instead of subtracting, we're going to be adding. That's very similar to the idea I just said a few minutes ago. We're going to be given a problem that looks like this. 3x cubed minus 4x squared plus 2x minus 1, all divided by the quantity x plus 1. Well, the 0 that comes from the factor x plus 1 is negative 1, and I've written it over here in kind of what looks like a half of an upside down box. A few of you might be familiar with this synthetic division because you talked about it with your previous teacher, and others of you will not be familiar with it. I like to include my variables in mine only because then I don't get confused about what I start with and what I end up with. So what I'm going to do is I'm going to carry down the first term. And I'm only going to carry down the coefficient. In fact, everything I'm going to do throughout this whole thing is only going to involve coefficients. The only reason I put in the variables up here is so that I know what I started with. The next thing I'm going to do is I'm going to multiply these two things together, negative 1 times 3, and I'm going to write that in the box below that, negative 3. And then we're going to add everything down this column, giving me a negative 7. And then I'm going to multiply again, negative 1 times negative 7, and I'm going to write that up here, positive 7, and I'm going to add these two together, and I get 9. And then I'm going to multiply these two again. Negative 1 times 9 is negative 9, and I'm going to add these together and get negative 10. Now what do we have over here? We have our remainder. And here we have our constant term and our linear term. and our quadratic term. So this is 3x squared minus 7x plus 9 plus negative 10 over x plus 1. Once again, not going to use the whole R. Okay, we are definitely just going to be big boys and girls and use our remainder over the divisor, like everybody else in the world. With synthetic division, a lot of people like it because it seems a lot simpler. And you can only use it when you're dividing by a linear factor, but that's okay. In Algebra 2, we're only going to stick to dividing by linear factors. So you'll practice some of that in class. It's pretty easy. Story problem. In example 4, there's a story problem that talks about the volume of a rectangular solid. They're talking about a sarcophagus or casket. I know several of you are laughing at me right now. The volume is equal to the length times the width times the height. Any rectangular solid would be the same. They tell me that the volume of this is v of x, right? That's our fancy function notation that we've talked about before. It's kind of like your y variable, but they're saying that it's called the volume. And the polynomial x cubed minus 13x plus 12 represents that volume. I want you to notice there's a missing quadratic term. A missing quadratic term. That's going to come into play here in a minute. Well, they tell me that the length is equal to x plus 4, and they ask me to find the width and the height. Well, the only way I'm going to be able to do this is to divide. So, I take the 0, which comes from the factor. The 0 that comes from x plus 4 is minus 4. And I'm going to use synthetic division. Notice here the missing term, right? It came into play. I had to include a 0. We carry down the coefficient. The coefficient here is a 1, right? 1x cubed. We multiply and add and multiply and add and multiply and add. And we're really, really happy that we got a 0 over there, right? Because that means that they were not lying to us. X plus 4 really is a factor. Okay, plus that helps us understand that we got the right answer. So we have x squared minus 4x plus 3. Now the only way to find out what two things multiply together to give me x squared minus 4x plus 3 is to keep factoring this thing. So we got to think about what in the world factors together to give me two things. Let's see here. Both the same sign, both have to be a minus, and the only factors of 3 that we can use are 3 and 1, and they happen to add up to 4, so that's beautiful. So I don't really care if you call this the width and this the height, or you switch it around. One of them has to be the height, one of them has to be the width. I don't really know which is which, so you just have both the dimensions, and that's really all they really wanted to know. The last thing I talk about in this section is called the remainder theorem, and I'll show you what the remainder theorem says. It says if you take this polynomial and you divide by some factor or some expression, a linear expression obviously, then P of A is the remainder. Now what does that mean? It means if you take the 0, right, the 0 from this factor is A, and you plug it into the numerator, what you end up with is the remainder. That's kind of nice, right? If you go back to example 2, we wanted to know if x plus 4 was a factor of x squared plus 6x plus 8. Finding the remainder would have answered the question without having to use division at all. In other words, we started off with P of x equals x squared plus 6x plus 8. We wanted to know if x plus 4 was a factor. The 0 that comes from x plus 4, what is that? Negative 4. So the remainder theorem says, hey, if you go plug negative 4 in here for all the x's, then the number that you get at the end is your remainder. And if you plug in negative 4 here and here, We get 16 there and negative 24 here and 8 obviously at the end. And those all add up to 0. The remainder is 0. Therefore, the remainder theorem helped me answer the question. And now I can say, yes, x plus 4 is a factor of x squared plus 6x plus 8. So the remainder theorem just went quicker. And those are all the notes that we have for section 6.3. And we'll bring those notes with you tomorrow in class.